Hello, in this video we look at factoring differences of squares. So first, let's look at the general pattern. Let's start with a very simple product of two factors. Let's start with a plus some b. Remember, later on these can be more complicated expressions. This could be, for example, 3x squared or even something like 2x plus 5. But for right now, let's start with something simple. A plus b times a minus b. Now let's expand this. So remember how we do this. We take the a and multiply it by this entire expression, and then we take the b and multiply it by this entire expression. Starting with a, we go a times a squared. A times a minus b, minus ab. B times an a is a plus ba, which is the same as a plus ab. Commutative law of multiplication. And then plus b times a minus b gives us a minus b squared. So it should be obvious that minus ab plus ab gives us 0. So this leaves us then with a squared minus b squared. And here we have our pattern. So whenever we have a difference of two squares, any a squared minus b squared. And remember, we are just establishing the pattern. These a's and b's can be substituted by other expressions. This is going to be equal to the first expression plus the first plus the second. Sorry about that. So that's a plus b, the first plus the second, times the first minus the second. Of course, you can always say a minus b times a plus b, because multiplication is commutative. Remember always, 3 times 4 is the same as 4 times 3. In both cases we get 12. Okay, so let's look at some examples. Here we have a to 1 minus y squared. So the first thing we have to do is make sure we recognize that this is a difference of two squares. And in this case it's fairly easy. This is 9 squared minus y squared. So this factorizes down to 9 minus y, 9 plus y. And so we go from a difference of two squares to a product of a difference and a sum. Let's take a look at this one. Here we have 16b squared, so let's rewrite this as 4b quantity squared minus, and this is also a perfect square, that's 1 squared. So now this becomes 4b minus 1, 4b plus 1. Okay, so now let's look at this one. 121a squared minus b squared. This is a perfect square. This is 11a everything squared. Remember, this exponent affects both factors in here. So that's 11a quantity squared minus b quantity squared. And so this becomes 11a minus b, 11a plus b. Again, now we have our expression factorized. In this case, again, we have two perfect squares. So that's xy quantity squared minus 3a quantity squared. Notice 3 squared 9, a squared, a squared. And so this becomes xy minus 3a, xy plus 3a. Notice again we have a product of two factors. So this expression has been factorized. In this case we have 2x quantity squared minus 3y quantity squared. So this becomes 2x minus 3y, 2x plus 3y. And so now we have a product of these two terms here. And now we look at this last one, and remember I said the a's and b's that we use to establish the general pattern can actually represent more complex expressions, as we see here. So actually in this case it is easier because the expression is already a difference of two squares that are very obvious. So this becomes then y minus, and let's keep these parentheses, 2w plus 1, and then keep the bigger parentheses. So notice now this is like my a, and this entire thing here is like my b. A minus b, and then I need my a plus b, so that's like my y plus. And let's just keep these for now. So I'm keeping these groupings so that I remain in control of my quote-unquote a's and b's. So this is a minus b, a plus b. And now let's fix this up. We can get rid of these inner parentheses, and this becomes y minus 2w, and be careful now, minus 1. Minus times plus minus, and then here we go, y plus 2w plus 1. And we're done. We have a product of two expressions here. So that's it for this video. Bye for now.